So the question is, given a pitch class set with some number of elements, we know now how to find the number of subsets of a particular size. And we use this formula, the binomial coefficient, in order to do that. The question now becomes, how do we determine the actual content of all of those subsets? So to demonstrate this, I'm using the example of a 5-element pitch class set, so a pentachord, and this set has the elements 1, 2, 3, 4, and 5. Pretty simple. And we're gonna determine the contents of all of the trichord subsets, so 3-element subsets of this 5-element set. First of all, we know how to determine how many subsets there are. So we just use this formula. In this case, our n is 5 and our k is 3. So that's 5 choose 3, our 5-element subset, and we're going to choose 3 elements. How many different ways are there to do that? So let's quickly just plug this in and find out how many there are. So that's 5 factorial over 3 factorial times 2 factorial. Expanding that out, we get 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. And then with some simplification, we find that that equals 10. Cool. So we have 10 trichord subsets. Now to determine what those 10 subsets actually are. So over here, I've written out the elements of the pentachord in 10 different rows. And this is just going to make it easy for us to determine, because all we're going to have to do in each row is just circle the elements that we want to include for a particular trichord. So there is an algorithm to doing this, and if you follow the algorithm, it will ensure that you don't miss any subsets, and you also don't double count any subsets. So to start with this algorithm, we're going to circle the 3 leftmost elements in this top row. So that is 1, 2, and 3. Okay. So that gives us our first trichord subset, which is just 1, 2, 3. Great. To get the next one, we're going to take the rightmost selection. So that is our 3 right here. And we're going to move it 1 step to the right. Everything else stays the same. So 1 stays the same, 2 stays the same, but 3 gets moved 1 step to the right. So that gives us our next trichord subset, 1, 2, 4. We're going to do that one more time. The first 2 elements stay the same. The third gets moved 1 step to the right. So that gives us 1, 2, and 5. 1, 2, 5. Well, now we can't move our rightmost element to the right again because it's already as far to the right as it can go. So the next step is to go 1 element back. So that's our middle element. And this time we're going to move that one to the right by 1. So 1's going to stay the same. Our first element's going to stay the same. Our second element is going to get moved to the right this time. That gives us 3. And then our third element is going to get pushed as far to the left as possible without going, backwards past the 3, because that would defeat the purpose. So our third element is going to be as far to the left as possible. That makes it 4. So this trichord subset is 1, 3, 4. Now we just repeat this process, and we keep moving the rightmost one to the right until we can't anymore. So 1 stays the same, 3 stays the same. We're going to move the rightmost element to the 1, giving us 5. For subset 1, 3, 5. Okay, now we've had the same problem, so we're going to do the same thing. The leftmost element stays the same. This time our middle element moves to the right, because remember we got this one to the end of the row. We can't move it to the right anymore. So this one moves to the right. And then the rightmost element is going to be written as far to the left as possible. In that case, that's just 5. That's the only one left. That's our subset 1, 4, 5. So now both of our our second and third element are all the way to the right. Neither of them can be moved any farther to the right. So now we go back one more element. So we're not moving this element. Well, yeah, we're not moving this element to the right. We're not moving this element to the right because they're both to the right. So now we're going to take our very first element and move it one step to the right. So that gives us 1. Move just to the right is 2. And then take both of the ones remaining and push them as far to the left as possible. 3 and 4. For our subset 2, 3, 4. Same thing now. We just keep repeating this process all the way down. So 2 is going to stay the same, 3 is going to stay the same, 4 is going to get moved to the right. Now we can't move 4 to the right, or now we can't move our third element to the right anymore. So 2 is going to stay the same, 3 is going to get moved to the right, and 5 is going to be as far to the left as possible, which is really the only number remaining. Now both of our last two elements can't be moved to the right anymore. So our first element is going to get moved to the right, 3, and then the remaining 2 are going to get pushed as far to the left as possible, which is, in this case, just the only two remaining numbers, 4 and 5. So that makes our last 3 subsets 2, 3, 5, 2, 4, 5, and finally 3, 4, 5. So that's how we determine all 10 of these subsets, and by following this algorithm, we know that we haven't skipped any, and we also know that we haven't accidentally double counted any. And a good way to check your work with this is, using the binomial coefficient. We know what number we should have had. It should be 10, and we ended up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sure enough, so we can be pretty confident that we counted them correctly. One thing that helps me with this process is sort of thinking of this like using an abacus. So on an abacus, you have, multiple rows of beads, and you move the top one to the right. And once you get it all the way to the right, you push it back to the left, and then move the one on the next row to the right. And you just keep repeating that process. In this case, it's sort of like all of the beads on the abacus are in one row. So 1, 2, 3, and then 3 gets moved to the right. Once it's to the right, the next one back gets moved, and then you push the bead to the right as far to the left as it can go. But if that's more confusing than helpful, then, feel free to think of it your own way or however you want. But that helps me. That's a good way to think of it. And ultimately, you don't have to write out all of these rows, especially when you get to like really big subsets like 8 choose 3. Trying to write out 56 of these with all of the circles can get cumbersome. And so you can kind of just get a hang of going, okay, 1, 2, 3, 1, 2, 4, 1, 2, 5, 1, 3, 4, 1, 3, 5, 1, 4, 5, 2, 3, 4, 2, 3, 5, 2, 4, 5, 3, 4, 5. And it just becomes a process that's a little bit more intuitive.